Everyone, we are going to be using those properties from quadrilaterals in all sorts of shapes now, referred to as polygons. So our learning target is that I will be able to use properties of polygons to find interior and exterior angles in polygons. So first, just a few definitions. We have regular versus non-regular polygons. So regular polygons are some examples right here. And what makes a regular polygon regular is that all angles are equal. So all interior angles are equal. But if you look at our non-regular polygons down here, you can tell that not all of these angles are going to be equal in each of these shapes. All right, we have convex versus concave polygons. Alright, so our convex polygons are when all vertices point outwards, and this is going to be an example right here. So if we look at all the little vertices on this polygon, you can see that they're all pointing outwards. But if you look at this concave polygon over here, if you look at all the vertices right here, these are pointing inwards, so that is why it's concave. Alright, and last but not least, our interior versus exterior angles. So your interior angle is inside, interior of the polygon, whereas exterior is outside of it. Our interior and our exterior make a line, which means they are supplementary. So what does that mean they equal? Alright, if you said 180, you're correct. So interior plus exterior angles equal 180 degrees. Alright, so now let's talk about how to actually find the measures of interior angles. And we're just going to walk through finding the formula for the sum of interior angles. So the first thing I want you to do is draw triangles from one vertex. So if I pick this vertex over here, I want to see how many triangles I can make in my polygon. So I'm taking from the same vertice to each of the other ones until I can no longer draw any more triangles. So I see that I drew 1, 2, 3, 4, 5, 6 triangles. If I multiply 6 times 180, I get a total of 1080 degrees. Why do you think we multiplied by 180 here? If you said because that's what the sum of angles in a triangle equal, you're correct. So the sum of angles in a triangle equals 180. You guys should know that by now, I hope. Alright, so then that means the sum of all the interior angles is what we found up here, 1080 degrees. If you don't want to walk through this process every time, this shows us where our formula comes from. So the formula over here you're going to want to remember is 180, coming from those triangles, times n minus 2. Over here, I want you to make a little note that n equals the number of sides. So n stands for the number of sides. So in our example over here, 180 times 1, 2, 3, 4, 5, 6, 7, 8 sides. That is equal to 180 times 6, which equals 1080 degrees. So you can see that we get the same thing whether we use the formula or we take the time to draw all the triangles. Alright, so that is how we find the total sum, so the sum of all the angles. Alright, to find the measure of just one of the interior angles, I need to start out with what is the sum of all the interior angles. So this is the same shape up here, an octagon, so I know that it is 1080, because I already found it up here. How many sides does it have? Well, when I counted, if I count again, I see there are 8 sides. So what I want to do is divide the sum of the interior angles by the number of sides. So I take 1080 divided by 8, and that equals 135 degrees. Again, I can give you the formula for that, so if you don't want to walk through this process every time, you can just use the formula that 180 times n minus 2, just like up here, but now we divide that by the number of sides, is going to be the measure of just one interior angle. So our example, like we just did, is 180 times 8 minus 2, all divided by 8. And when you type that in your calculator, you're going to get 135 degrees, which is the same as we got over here. All right, let's try out one example problem all together. So looking down here, we want to assume that all of these are regular polygons. That would be given to you in your directions, and I'm giving it to you now. So below is a quadrilateral. Quad should tell me 4 sides. So 4 sides in the polygon. The sum of the interior angles, that's going to be my first formula up here. So 180 times n minus 2. Here is 4 minus 2, which is 180 times 2, which is 360 degrees. It's going to be a huge piece to remember that quadrilaterals always equal 360. All right, now the measure of one interior angle is my second formula up here. 180 times n minus 2 divided by n, which is 180. 4 minus 2 divided by 4, which equals 90 degrees. All right, go ahead, flip it over, and we just need to do exterior angles, and we are all done. Okay, so how to find the measure of just one exterior angle. So from the front of our notes, we were doing an octagon on all those other formulas. So we had found that the measure of just one interior angle was 135 degrees. You can flip it over and look for yourself if you don't believe me. All right, so I'm going to draw over here on my shape that this was 135, excuse me. And I'm going to be looking for the little X right there, that exterior angle. So to find the exterior angle, it's pretty simple. We're just using supplementary, the fact that it equals 180. So if our interior angle is 135 degrees plus whatever that exterior angle is that we're looking for, that's going to equal 180. So all I need to do is subtract 135 from each side, and I end up with X equals 45 degrees. So that is our exterior angle. All right, great job, guys. We will finish the rest of it in class.